Okay, this is GCSE Physics Year 11, Unit 1, Static and Current Electricity. And this is podcast 1 about static electricity. So we've divided the unit up into two parts, static electricity and then current electricity. I'm not sure if you can see this or not. This is just a diagram of an atom. So to start off, what we want to talk about first of all is the structure of an atom, because that really explains why we have static electricity in the first place. So this is an atom. You've learned this down the school, you've learned it in chemistry, but what you have here is a nucleus, and in the nucleus you have protons which are positively charged. You can see them on your diagram, they're in red, and joined to them in the nucleus very, very tightly with a huge amount of energy is neutrons. Now there may not necessarily be the same number of neutrons as protons, but in an ordinary atom, in a neutral atom, there are always the same number of electrons as protons. So in the atom there are electrons and they're surrounding the nucleus. They're moving around the outside in what we call shells. In the first shell there are 2 electrons, one here and one here, and then in the second shell there are a number of electrons, up to 8. In a neutral atom, the number of electrons is equal to the number of protons. Protons have a positive charge, electrons have a negative charge, and they cancel each other out. The charges cancel each other out, and that means that the overall atom is neutral. Okay, so the overall atom is neutral. Electrons are negatively charged, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons in this particular atom, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 protons in the nucleus. So just a wee bit about the charges and so on. In the proton, I might zoom this in a little bit so that you can see it, hopefully a little bit more, might be a wee bit better. In the atom you have got protons in the nucleus again, and they have got a positive charge. Neutrons in the nucleus, they have no charge, and electrons, which are in the shells around the outside, and they have a charge of -1, or they're negatively charged. Okay, so why are some materials conductors and other materials insulators? Some of them allow electricity to flow through them very easily. They're called electrical conductors, and others don't, and they resist electricity flowing through them, and they're called insulators. Now we have to go back to the structure of the atom again to see why this is. And here again we have a copper atom, and in the copper atom again you have got, in this particular case in a copper atom, you have 29 protons. Now around the outside you've got 29 electrons, but as we said earlier, they're arranged in shells, and those shells determine how much energy they have. The first 2 are held very tightly in this shell because they're very close to a positive charge and they're negative. The next 8 are held just not as tightly, they're a little bit further away. The next shell has actually got 18 electrons in it, and it's a further distance away again, but it's the last shell we're really interested in, because this is the 29th electron, and it's actually held quite a distance away from the nucleus, quite loosely. And that means that if it's given a little bit of energy, it's able to move, and once it moves away, then this copper atom is then left with 29 protons, but only 28 electrons. So it has an overall charge of +1, and then it becomes a copper ion. But it's this little electron which is moved away which actually adds to the current in the circuit. And we know that current is a flow of electrons, and therefore it's this, we call it a free electron because it's able to move quite freely, and it moves away, it constitutes a current. And that therefore is a reason why copper is such a good electrical conductor, but things like plastics and so on and wood, they wouldn't have a free electron on the outside, or free electrons which are able to carry current, and so they are actually insulators. So hopefully you'll be able to see this a little bit more clearly. Now, we have drawn, generally in chemistry and so on, we always draw our electrons with these simplistic shells, and you can kind of see them outlined here. But in reality, what actually happens is electrons orbit in all directions, but they are found generally within an energy level, and it really does depend on their distance away from the nucleus. So you can see there, you've got electrons in a certain level. In round here, you can see these circles just very, very faintly, and you have 2 electrons in this one here, and you have a number of electrons in the next one, a number of electrons in the next one. But it's this last one we're so interested in, a little energy and away it goes. And this leaves your copper atom as a copper ion because it's lost an electron, and this adds then to the electrical current in the circuit. So just a wee tiny bit more about metallic bonding, and we'll just zoom out a little bit so you can see all of this. Okay, so metallic bonding, again, we're still talking about conductors like copper, like silver, aluminium, all those metals. They all have a similar structure, and what they have is, as we explained about the free electrons, given that they have outer electrons which are quite able to move throughout the metal itself, the way it's formed, or the way it's made up, is that there's a number of metal ions, so ions which have lost at least one electron, and then in between it's got all these little electrons which are able to move freely throughout the structure of the whole thing. And I'll just zoom in a little bit. And we call this a lattice, this shape, we call this shape a lattice. So this shape here is a lattice because the metal ions are arranged quite regularly, and in between you've all these freely moving electrons which just randomly move throughout the copper or whatever it is, unless you put a potential difference across them or a battery. So if we connect them into a circuit with a battery, this side positive, you can't see that, so I'll just zoom out a wee bit. So if we make this side positive and this side negative, electrons are negative, and so they are pushed away from the negative side towards the positive side, and this becomes a current. All the electrons within the metal and within all the wires that are connecting it constitute a current, and they move towards the positive side of the battery. And that's why things like copper are such good conductors. Plastics, insulators are no good. They haven't got free electrons which are able to carry the current and move.